Good morning, this is Bruce. As you can see, the sun's coming up, so I wanted to make this short morning talk before the sun gets too much in my face. This is a linear algebra book. It's a math book. I've told you that this is not going to contain math or much math. We're not going to teach math, but we're going to talk about it. And you know, it's tempting to say, I want to tell you where it went wrong, but math doesn't go wrong. It just goes in a direction that's not particularly helpful for us in a social sense, in a spiritual sense. So math has gone sort of in an unfortunate direction for the embracing of self, other, and belonging, and understanding what math has to say about that. Because as I've said before, math has focused on mastery, on measurement, prediction, and control of material and material properties. So I want to introduce you this linear algebra, what comes out of that, and this is from my college years, my graduate degree, and I'll tell you, I'm really proud of this book because in the front face, I don't know if you can see it, that is Neil Armstrong's signature. The only signature that I've ever asked for, because I did meet him after the moon landing out at USC. I don't know if you can see this very well. You know, so I'm going to tell you about mathematics, and I'm going to tell you something about where it has gone in an unfortunate direction for us historically. Fortunate material-wise, we shouldn't complain, but we do need to understand how it is not exactly good for us in another direction. So this is a coordinate system, and what I want to point out is the idea of pointing directions. This is a pointing device. And so, you know, you're all familiar with if we're going in some direction, then with respect to a coordinate system, we can describe it as a certain amount in this direction, a certain amount in that direction, a certain distance in this direction. So we use this coordinate system to quantify a direction and a distance. So now if we look at this pointer here, you know, you can point it anywhere, all the way around you, anywhere. That space is what we call in here a pointing space. And mathematically, a pointing element like this, where you have some starting point, that little blue block stands for the starting point, origin, as they say. With respect to that place, we're going to point in some direction and define a distance. So this little pointing stick is pointed in some direction and it has a distance. And this gets back to, in an earlier one, we talked about how if you specify, well, we didn't talk about this, but we talked about squares. So if you specify this pointing direction and distance in terms of x, y, and z, then you get those energy squares, x squared plus y squared plus z squared. Or we get squares. This distance, the square of it is the sum of the squares of the component distances. Now, you know, I don't care if you don't remember that. I don't want you to remember that. What I want you to remember is that this pointing space around us is a vector space. I mean, so we're not going to use that word very much, vector space. This pointing thing is called a vector. And here's the problem with math. It was discovered hundreds of years ago, 150 years ago or so, that you know, we have x, y, and z, and we know that defines a pointing direction. Well, mathematically, you can have x, y, z, and w, and as many elements as you want, and all of the same operations hold. The direction and distance idea, the idea of rotation of a coordinate system. You know, if I take this to be my coordinate system, where this means forward, up, to the right, then, you know, I can change the coordinate system any way I want. And still, I'm facing the same direction. The vector is not moving, but you can change the coordinate system. That's complicated. And that is what you learn how to do when you learn linear algebra, and you learn pointing space mathematics. So the problem is that pointing space mathematics goes easily up to higher dimensions. All of the operations work, angles work, rotations work, direction and distance works. The sum of the squares of the components is equal to the length of the pointing stick in this higher space. See, that's the thing. There can't be any real pointing sticks when you get above 3. You'll see just all kinds of literature about a fourth dimension. And, you know, it's been determined for sure that our existence is far deeper than just the 3 dimensions that we can point in. So I call that the 3 dimensions that we can point in are pointing space. So we've known, and space-time says this, and there's all kinds of books on the 4th dimension. It was a spiritual subject of conversation back at the turn of the century, when 1900s going to around 1900. So the idea of a 4th dimension has been in the works for 150 years or so. And so, you know, there is an added dimension. But where math goes south, where math heads us into bad interpretations as far as our mystery and understanding self, other, and belonging, math takes the route of using that, of treating a higher dimensional pointing space as if it conforms to reality. So they're always facing some kind of dilemma. How do you find another stick that is perpendicular to all 3 of these? And you can't. But what we will find is that business that we showed about squares and treating them as a resource to be allocated. So using the Pythagorean theorem not as a perpendicular thing, but as a resource allocation thing, then you can rein in the sort of wrong direction socially of mathematics. So you can have the 3 pointing dimensions, and you can have an inner dimension of inner energy. So I just wanted to record that. This may be a thing that I do over, but I wanted to capture it this morning. So thank you for listening, and see you next time.